happy to have Doug Rivers here with us from Stanford, and he's going to be presenting on what the hell happened, the perils of polling in the 2016 U.S. election.
Thank you. So I'm going to start talking about what the hell happened in the election, which is not my topic for today. The real topic is what happened with polling in the election. But I thought I'd spend 5 minutes giving you my version of what happened. Oh, well. After the 2012 election, the Republican Party held a postmortem on what happened, and they came to the conclusion that they did really badly among blacks and Hispanics, and they needed to address that problem. In 2016, they had a candidate that basically wrote off blacks and Hispanics that Republicans did badly with, did everything possible to lose women, offended white males with college degrees, and went after this group. And he won the election. I didn't think that was going to be I gave a bunch of talks before the election saying this was a loser of a strategy since there weren't enough people in here who would have guessed how complicated it could be. How did that happen? Well, the simple version is a question that the people who work for me make fun of. They call it the kumbaya question. So we ask people in one of these standard kind of polling questions, which is you read them two statements that are extreme and ask them which comes closest to their position. So on the one side is if you think of the Trump campaign, that's basically their version of the world, that there are a lot of evil terrorists, criminals, illegal immigrants out there, and we should do everything we can to protect ourselves. And the Clinton campaign, went after being inclusive and, was a generally positive view on the world, even if she retreated on trade. And this question is almost as good as asking people how they're going to vote in terms of classifying them across these two things. That is, almost 80% of the Trump voters go with the dark vision of the world, and about the same fraction of Clinton voters go with the kumbaya response. So that's essentially what their campaign messaging was. And then what happened? Well, it turned out there was if you look among whites, which is the way you need to look at these things to keep from getting confused, was that in this election, Trump managed to polarize men and women and low and high education voters. So among whites, the gender gap went from about 7 points in 2012 to about 12 points in 2016. These are exit poll data. And then if you look within gender groups at the education gap, that is the difference between how college graduates voted and non-college graduates, you see it goes from 6 points to 17 points. And among men, it goes from 5 points to 16 points. So you have a near doubling of the gender gap and a near tripling of the education gap. So essentially, the message that Trump had managed to separate whites across these groups. And in the end, he ended up essentially winning white non-college women, which I didn't think would happen given his biography and his campaign, and won both the male groups. So essentially, it was the white working class, defined here as white non-college graduates, are the ones that got Trump over the finish line. So let me move on to the polling. I've had sort of three misses. The UK 2015 general election I thought would be close. Brexit, we had that as a toss-up. and I had Trump in the 2016 election, so I'm about 0 for 3 running here. So here's some lessons that we took from the various kinds of polling problems that occurred. So the party line among pollsters, there's an APOR report that's going to be coming out in May, is essentially there really was no problem that we said Clinton was going to win. She won by 2 points. There are these sort of scruffy state level polls that may have had some problems, but the sort of stuff that the networks do and so forth was just fine. I think if you scratch beneath the surface quite a bit, you can find lots of problems. And so the first problem is with weighting. So briefly, the bulk of the polls are weighted using some sort of post-stratification approach. So the idea is after the fact, you divide the sample into strata, really post-strata. Since they aren't part of the design, you calculate the mean within each strata. You weight by the known fraction of the population in the stratum. That's equivalent to weighting the individual observations by the ratio of the population fraction in the stratum to the sample fraction. There are variants of this, such as raking and so forth, but they all pretty much amount to this kind of estimator. So what are the problems? The first thing is because we're dealing with sub 10% response rates or in online panels, self-selection, there are a lot of things that are associated with what the who gets included in the sample. And a reasonable model will have a lot of variables because there are a lot of things that you can fix in the data. So if you choose a lot of variables, that is, you fit a complicated weighting model, you tend to get big weights. One network, for example, says they trim their weights at 7, which means they're routinely getting weights that are bigger than 7x skews in the data. I know from stuff I've looked at, if you do a kind of reasonable weighting model, you can get weights that are 30, 40, 50 and sample of 1,000. So that's saying that one observation can flip the result by 3 to 5 points. So what do you do? The routine thing is you take the big weights and you make them smaller. So you say, if I don't want any weights bigger than 4, I'll just make the maximum weight 4. And what happens there, of course, is that trimming the weights causes bias. That is, instead of weighting by the true population fraction, you're weighting by something else. It does reduce the variability of the estimates when you have smaller weights. But if you think about it, you're solving the wrong problem. The thing that's known is the population fraction in each stratum. The thing that's bad is the estimate of the stratum mean because it's based on a few observations. And the right thing to do here is to improve the estimates of the stratum means, by some sort of shrinkage or barring strength across stratum, not by trimming the weights, which is what's routinely done. So Mr. P, which is a very old idea in the survey literature, it's known as small area estimation, uses hierarchical Bayes to estimate the stratum means. So you're going to have a model that's going to use essentially patterns across the different strata to fill in better estimates for the places where you're lacking decent sized samples. Now, this has gotten quite popular, this approach. It turns out in practice, it's what we did to produce our daily estimates in 2016, which I'll go into in a second. But if you look at the sort of textbooks descriptions of this, there are 2 parties, everybody votes. and you got 3 or 4 variables that are in your model, like, they're all demographics, and you just go to the census and you get the data. Well, in reality, there was Clinton, Trump, Johnson, Stein. There's a smattering of people saying they're going to vote for somebody else. I don't know. Who's the guy who ran in Utah? He was on a few ballots. There are people who say they're undecided, and there are people who say they're not going to vote. And then there's a turnout question that attempts to measure likelihood of voting. So your response categories start to explode. You're not dealing with a dichotomous response. And then furthermore, what do you multiply those things by? Where do you get these stratum sizes? The assumption is you just go to the census and you copy these numbers down and they're available to you. Well, in reality, we have a variety of data sources. The main source people use is the American Community Study, which has a public use microfile that has a geography called PUMAs, which are, I don't know, about 100,000 people each. But there's no data on registration and turnout. That comes from the current population survey, which doesn't include any PUMA identifiers or congressional districts. So we chose congressional districts as being a kind of reasonable geography to work with because they're roughly the same size across the country. But the census doesn't put congressional district on any of its public use microfiles. So the first thing we have to do is to be able to impute congressional district to the census data. So the method that we use is we try to estimate a probability that a respondent is in District J conditional on the respondent's characteristics, XI, their demographics. So the marginal probability of the persons in the district we get from doing geographical overlays of what fraction of the congressional district is in each PUMA. And then we multiply that by the fraction of people in the congressional district J that have characteristics XI. This is Bayes' rule. And it turns out the census publishes tables of these every reapportionment period. And that gives you a reasonable probability that we can use to impute congressional district onto the file. Then the next thing is voter registration. So what we've done is we estimate a Logit model using the current population survey, registration and voting supplement in each state to estimate the probability someone's registered or votes. The CPS doesn't tell you how they voted. There are at least 1,000 observations in each state to estimate this, so there's a second imputation. Then the third thing we do is we impute presidential vote from the exit poll, conditional on you having voted using exit poll demographics. At this point, things have sort of gotten a little bit off, so we rate the weights to match the actual turnout and vote in congressional districts. That's public records data. We then, at this point, have a 2012 file. People forget that people die between 2012 and 2016. I'm amazed that Nate Cohn has these pieces on the data was off because the recall was that Obama got more votes than he actually got. Well, turns out 5% of the population has died between 2012 and 2016. And almost all the people that died are over age 70. And the people they've been replaced with are ones who are now between the ages of 18 and 21. And it turns out there's a 40-point difference in how those people vote. So how do you fix that? Well, what we did is we applied a life table to this data to age it 4 years into the future. Okay, very basic. I know you could probably do better with fancier methods, but at that point, we look at the data and we notice we've screwed up a variety of things. We have way too many people without a college degree who are people who were under 18 in 2012, who are now 22 years old and so forth today. So they have higher education. They weren't registered to vote then since they weren't eligible. So we do a model-based imputation of that. And then when we're all done, we match the stuff to the latest ACS, which gives us what we call a sampling frame. It's not a sampling frame. It's essentially just a file of targets to use for sample selection, weighting, and estimation. Anyhow, so this is an example of kind of the range of things you got to do to get reasonably close to getting this right. So we estimated a model that includes demographics and 2012 vote at the state level. And it's a hierarchical model with shrinkage at various points and so forth. I'll explain later why 2012 vote's important, but here are the estimates, the final estimates that came out. The computation of this was pretty challenging. We used 37 cores on AWS and were able to estimate 50 iterations of each chain. So having 37 chains got us to kind of reasonable number where we thought we'd reach convergence. The print's small, so you can't read where we made mistakes, but to give you the feeling of it, I can read them here. So this is the 50-50 mark on vote. Here's our national popular vote estimate, which had Clinton up by 3.8%. And you see that we had Clinton ahead by a little bit in Michigan, Wisconsin, Colorado, North Carolina. We actually had her ahead in Georgia, which is a thing that never seemed to change over the election. Pennsylvania was close, Iowa, Nevada, Florida, Ohio. So basically all the stuff that was in play was in the middle here. Our numbers weren't all that different from other people's numbers. The main differences were that we had Pennsylvania close throughout the election, something we told the Clinton campaign, and they told us we didn't know what we were talking about. We also had Wisconsin within the margin of error. We didn't have Michigan. So I did this work with Ben Lauderdale, who tweeted about it. And what Ben said, which I wish I had said, was that anyone that thinks Trump cannot win is delusional. Our polling has Pennsylvania a lot closer than most others. We could be wrong, but winning there opens up a very plausible electoral college path for Trump to win. If Trump wins the election, there's a very good chance he'll do so while losing the popular vote. Pretty good, I thought.
Do you have working for you, by the way?
On the other hand, I looked at it and I said, looks to me like Clinton's going to win. And there is this debate out there about poll herding. And I know we used to be much more subjective in our weighting. And what happens is you do various weighting models and you look out, and if your weighting model gives you about the same answer that other people have, then you go, that must be the right one. So I've gotten much more to the point of you have to do it mechanically and sort of bite your tongue at stuff where your friends make fun of your estimates. But the fact of the matter is, I looked out there and everybody told me Clinton was going to win. Our models showed her ahead. Seemed like it was a safe bet to make. So what went wrong? Well, the national level estimate, we were too high. Basically, the average poll was too high in 2016. The average poll was basically a 3 to 4 point Clinton lead versus the 2 points that was the final margin. However, that's better than 2012. Obama won by nearly 4 points, and there wasn't a single poll that had Obama ahead by 4 points prior to the 2012 election. So the overall bias in the national polls was less in 2016 than 2012. In 2016, some people overestimated Trump's margin, including there were a couple polls that actually had him ahead in the popular vote that after the election, various people declared these were great polls. But the fact of the matter is, of course, presidential elections are determined by the Electoral College, so you got to effectively make estimates for each state. And it's a lot harder to make states 50 estimates than it is one estimate. I think that's sort of obvious. And so here are final battleground polls in the last 3 weeks. Again, this is a bit of an eye chart, but the structure is the vertical line is the actual outcome in each of these states. The points are estimates with reported margin of errors. And some of them look pretty good. Like if you look at Arizona, you see some people were too high, some people were too low. We were the red dot. So we did better in some places than others. But, you know, you'd say, all right, the size of the errors is too big, but there's no, you know, obvious evidence of bias. Colorado's the same way. Florida, getting there. Looks like there are way too many on this side. Georgia's not bad. Nevada is sort of the opposite of Florida. And then they start to go off the rails. North Carolina only had a couple that had Trump winning. He ended up winning by 4 points. We were way off there. Ohio, nobody, all the polls were on one side of the actual outcome. Trump ended up winning by 9 points. Most polls thought that Trump had a small lead in Ohio, so people didn't really notice it. In something like Pennsylvania, nearly all the polls had Clinton ahead. You know, we thought we did pretty well there. And Wisconsin was another state where everybody was on one side. Okay, so you can't have those outcomes and have unbiased estimates at the state level. There's obviously something going wrong there. What is that? Okay, so the first thing is if you do a national survey and you balance by region, you essentially get a lot of random variation. Within regions, you get some red states and some blue states. And so national pollsters will have some sort of regional breakdown. If you look within states, so you go to the state level, you've got some red counties and blue counties. So Wisconsin was a very light pink this year, but within Wisconsin, there's a variety of regional variation. And if you're somebody like me, I've been to Wisconsin, I think, twice in my life. I don't know anything about it. We use some regional breakdowns to cover the state, but unlike local pollsters, we don't pay much attention to it because we don't know much about it. But you think the typical thing people do is sort of geographic strata. And the problem is that the geostrata here aren't going to deal with the fact that there are large areas that are deep red surrounding areas that are dark blue. So you're mixing those. And if you look within counties, you'll see the same pattern repeating itself. So Dane County is where Madison is, so it's pretty dark blue, but there is a little red splotch there. Those are precincts within there. Milwaukee, city of Milwaukee is dark blue. Its suburbs and collar areas are pink and red. Brown County is where Green Bay is. So you see the city here is pretty dark blue, and the surrounding area is pretty dark red. Okay, so none of that stuff is being corrected in the data. And we did not use, and no one that I'm aware of was using any kind of urban-rural differences. And one thing about this election is there were massive urban-rural differences. When people are talking about the white working class, what they're really talking about is suburban and rural white voters in those big sort of semi-empty parts of the map.
Why would that generate bias?
Well, if you don't have random selection, it's easy to have skews in these things that are uncorrected.
But did they not have random? I mean, they were trying to randomly select.
There is no random selection these days,
Right.
particularly in it. You know, so our stuff is purely opt-in. So we have no idea what the process is that people, so we try to look at things that are discrepant and try to correct them. One of the things we have not looked at was urban-rural differences. And they were big differences in this election on that. Something we're going to
There's
fix.
an omitted variable.
Yes. But we're in a world of, single-digit response rates for things that start with random selection. So there's a world of bad things can happen to you. So if you have anything that's correlated with vote, you probably want to think about how do I correct for that. Yeah, Matt?
Was the urban-rural thing, is that new to this election cycle in terms of the selection of the samples, or is it just, because of it interacted with the fact that the vote was so split, urban-rural, that we noticed it this time?
So precinct level data is hard to get. And that's what would really give you a lot of power in terms of I'll show you the next slide in a second. I'll come back. So if I were able to know that I had the right number of people in here and the right distribution within that, then it wouldn't make any difference a lot of other sorts of selection biases that I have. Is it new? Yeah, so there has been an increasing polarization at the precinct and county level. So if you look over the last 20 years, you see that they seem to sort themselves out the way the states do. But the lower the level of geography you go, the easier it is to fix the selection problems. And in fact, ideally, let me do this first. I don't know a lot about Wisconsin, but I have heard of Manitowoc County. If anybody's watched the Netflix series Making of a Murderer, it's a guy who's wrongly convicted rapist who may be a murderer in an auto salvage yard right here. Manitowoc County is, I think, 60,000 people. 30,000 of them live in the metropolis of Manitowoc, which is blue. It voted for Clinton. And this area out here, which is big redneck country, that Trump won that by 40 points. So that shows you kind of the range of things you'll see there. Ideally, we'd go down to the household level. So if you had a voter file that you had reasonable imputations of what the household partisanship was, turns out you could do really well. We asked people how their spouses voted. It turns out something on the order of 99% of the sample say they know how their spouse voted. So there's probably an extra % of disagreement that's just being covered up. But nearly all these things are on the diagonal. They either both voted for Clinton, both voted for Trump. Very few are essentially split votes. Yeah.
Sorry, can I ask a question about this county level stuff? So I'm sorry if I'm missing this, but is your point that in waiting to the county,
we didn't wait to the county.
So what was the unit that you waited to with it?
We had regional geostrata, the same as in the exit poll. Okay, so you divide the state into typically 4 or 5 geostrata. And those things have huge amount of heterogeneity within them in terms of their partisanship.
And so what you're saying is that essentially the way that a state like Wisconsin was, the reason it was wrong, the polls are wrong.
I'm getting to why it was wrong.
Oh, okay, sorry. All right.
But I could have saved myself a world of pain if instead of doing 4 geostrata in Wisconsin, we easily could have put the counties into 4 partisan strata, and that would have separated the blue parts of the state.
But why doesn't your last matching level fix all this? I mean, weren't you matching on urban, rural, and all these things?
No, we were matching. Urban rural is not a classification the census has ever been very comfortable with. So you have to sort of make up your own definition of what it is. The right thing is we have precinct level data, and that's how I think you can fix these problems. Because we know exactly where these people live. And if we fixed it at the precinct level, you're getting to a pretty homogeneous level at that point. You can take a lot of variance out. Okay, so why did we miss these states? It certainly wasn't news to us that white working class voters were voting for Trump, and that women were voting for Clinton. All that stuff was in the model. We thought we had it the right way. And the answer, it appears, is turnout. So I've been saying for years turnout doesn't matter. If you look at the composition of the electorate across elections, it's remarkably stable. That is, turnout goes up and down, but the size of the groups within the electorate, it really doesn't change much. So like the biggest effect we've seen since the CPS started doing this was blacks in 2008. So black turnout rates went up by nearly 10 points. The size of blacks in the electorate went up by 0.6 of a point. Okay, and that was with the first black presidential candidate. In our MRP model, first in surveys, what most news organizations do is they ask a question: will you definitely vote, probably vote, maybe vote, probably not, and so forth. And it turns out 90+% of the people you talk to say they're definitely going to vote, so they call those likely voters. Some people, what we do occasionally is we will assign probabilities to those that have been calibrated based on past turnout. So the people who say they're definitely going to vote get something like a 0.9, and the probably get about a 0.5, and the maybes of 0.1 and that kind of thing. But it turns out that if you try to look after the fact, our definitely won't vote category has something like about a 15% turnout rate. My lesson on that one, incidentally, was that a wording change could actually improve things a lot. So we've gone from a symmetric thing where it's definitely vote to definitely not vote to definitely to never. And it appears that reduces that bottom category by a bit. People may just be, because you're randomizing the direction of the scales, making mistakes. Yeah.
Are you matching to voter files to get that actual turnout percentage, or are you just asking them out?
That would be another 4-hour talk. If you're ready for the Castro length talk, I can give you that one. Okay. All right. So in this election, I was proven completely wrong on turnout not mattering. So here are the states that we had sort of our worst problems. What we've done is we've classified counties based on the 2012 Obama vote, ranging from the most red, where Obama got less than 35%, to the most blue, which is above 65%. And then we looked at the turnout change between 2012 and 2016. So if you look in Pennsylvania, what you notice is that in the red counties, turnout went up by 10 points. In the blue counties, it went up by substantially less. If you did this for 2008 to 2012, you'd see these bars are completely flat all the way across. That is, there was no correlation of the turnout change with past vote. Michigan, you see the same thing, pretty strong correlation. Ohio. What's happening in a bunch of these places is that population is decreasing. It's not that turnout was actually lower, it's there are fewer people, people moving away. North Carolina, less of a problem. So Iowa, some correlation. These are two counties. Any guesses as to what they might be? Anybody know Iowa? No.
It's Iowa and Iowa State.
Yes. So these are two college towns. Okay, and Trump did manage to mobilize voters in those places, and you find it around the country, that turnout. And so what's typically happening in states where you have urban areas with lots of blacks, you got blacks not turning out, but it's somewhat counterbalanced by in places where you've got college towns. All right, so that's the pattern in all the states where we had problems and most people had problems. If you look at the states where there weren't polling problems, battleground states, what you notice is there's hardly any correlation between turnout changes and past vote. So Florida, Colorado, Nevada, New Mexico, New Hampshire, Arizona. Yeah.
You said that the chunk of the turnout decline was being driven by people moving away, so they're not changing their voter registration or something? But I guess my question is, does like Cleveland have perpetually declining turnout because of what you just described?
So this is what the turnout change is, just the change in the number of votes cast. Okay, so it's making no adjustment for either population or registration. The voter list is great for telling you who votes. It's problematic for telling you what turnout rates are because different jurisdictions have different amounts of deadwood and so forth. Until somebody solves that problem, I'm perfectly happy using voter files to tell me how many men and women voted, but if you do these things trying to use registered voter turnout, you get kind of bizarre looking pictures. Yeah.
It's just a question of terminology. Given your inspiration as your, I guess, you're drawing standing on the shoulders of a Gell-Mann, he would always say, we don't have multi-level models, we don't have random effects, we have varying slopes and we have varying intercepts.
Yeah.
We're not varying. Well, these are varying intercept models. Is that right?
Well, these are, so the typical MRP model
Yes.
is purely a vote model. Okay, and what we did is we estimated completely in an ad hoc way a turnout model using validated 2012 vote. So we assumed that the conditional probability of voting given your characteristics is the same as it was in 2012. We applied that probability to the vote estimates within each cell of the post-stratification. The typical thing Andy has done doesn't deal with turnout at all. It presumes that everybody votes and you can use, population targets or something like that to post-stratify.
So you're not.
The right way to do this,
Yeah.
if you could do it, is to jointly estimate the vote preference and likelihood of voting, and to then use a calibration of the likelihood of voting.
Okay.
The problem is we started out in late September, and it was taking us 8 hours to estimate these models. On the Saturday night before the election, the amount of data had expanded to the point where it was taking close to 20 hours to estimate the model. So Ben would fool with the models in London, he'd set them off, and then we would see them the next day in Palo Alto. The weekend before the election, we basically bailed on Saturday night. That was our final estimate.
Could you, just to indulge those of us who are a little bit slower, could you say your ideal model that couldn't converge one more time?
Yeah, so the ideal model is you would use, instead of one variable that you're predicting, which is two variables, or flatten it into a single variable, but it's the cross classification of your presidential candidate preference and your likelihood of voting.
Okay.
And we're going to try this in the UK election. So essentially there's a model for your candidate preference conditional on your characteristics. And then there's a probability of voting conditional on your candidate preference. And we're going to do, in the UK, the standard likely voter screen is a 0 to 10 point scale, which we're going to just model as a linear model.
Okay, so just for clarification, because like a lot of social scientists, at least in sociology, we know our MLMs pretty well. Waiting post-stratification is something you put in afterwards.
Yeah, that's what this is.
Well, only you thought about it, right? So it's not an afterthought. But are you saying we shouldn't worry about, say, the varying slope of some of those demographic or education predictors of political action, political voting? Like, I'm thinking.
Yes. All right. So that's a good question.
In education in Kansas, I have a friend in Western Kansas.
Yeah.
Everyone will talk to him because he's the one with the college degree out of all in the farming community. So
So,
Context matters.
so
right?
these are varying slope, varying intercept model. Their main effects at the state level and their interactions at the regional level. We would like to be able to estimate interactions of all the variables at the state level. I mean, hell, I would like to estimate them at the county level. But you need a much faster method of estimation. So some shortcut methods of estimation are probably a good way to start here rather than doing full Bayes.
Okay. I would ask more, but
Turns out in an election campaign, you make lots of shortcuts. Okay, so here are a bunch of states, battleground states, that didn't have polling problems, where we didn't seem to have turnout effects. And this thing is definitely not universal. So if you look at some red states, you actually have positive correlations of turnout changes with past vote, okay, which is one reason why we underestimated in California and New York how well Clinton would do. And then there are places where this is a lesson. If you get the outcome right, people don't notice that it wasn't actually a very good estimate. So Virginia is a place where we missed, and South Carolina has this effect in spades. Indiana, because you get the outcome right in these places, people don't notice that the errors are actually relatively large. So I think there's a lot to be done using turnout. To show you what the overall effect is.
What's the substantive result? So, so how much of the turnout was actual just recruiting people, and how much of other was people moving from one kind of county to another and dying?
I don't think there's significant movement of people. The problem is with surveys, we know our turnout measures aren't any good. That is, the self-reports are overestimates, despite what you may have read some places. So the campaign pollsters pretty much use past vote, but that again is committing yourself to no changes in composition. And that's what we ended up doing after doing badly in 2014, using a probability weighting of the voter scale. We did a postmortem in 2014 and decided we would have done a lot better just using a historic turnout model. And we then, before 2016, we went back and we refit everything for 2012 using 2008. Worked perfectly. So.
No, but what's the substantive result? So, like, what behaviorally changed that we didn't notice?
Yeah. So. This was going to be my conclusion to the whole thing, but I'll give it to you here, since this is where it's relevant. After 2008 and 2012, we drank the Kool-Aid. That is, you do experimentation, you do analytics, you do GeoTV with these organizations and so forth. And that explains how Obama did so well, and then you start Civis Analytics and you make a bunch of money. In 2016, we've got the Trump organization, which had no organization. Analytics were pretty few and far between. And they didn't spend much of anything, and they managed to get these great turnout effects. And my view is what happened is the candidate, Obama in 2008 and 2012, managed to mobilize a lot of blacks just by who he was. And Trump did the same thing this year. And it's much less organization-driven and more candidate-driven. Well, candidate-driven is what really screws you in these things because, that's correlated with how people are telling you about their enthusiasm and so forth. One digression here. There's this USC Dornsife poll that Ari Capitan, good econometrician, runs. And it was the one that consistently had Trump ahead. And there was a pretty erroneous story in the Times about what went wrong there, and they claimed their problem was they were weighting 18 to 21-year-olds up too far. And you wondered, why did they have an 18 to 20-year-old black person getting a weight of 30? And the answer was they were waiting on past vote, which I'll come to in a second. And that didn't explain what was wrong with their survey. The problem with their survey was they were using this Chuck Mansky likelihood of voting for a candidate and likelihood of turning out. So you ask people on a 0 to 100 scale, what's the probability you're going to vote for a candidate, and you apportion that among the various candidates. Well, it turns out that the Trump people, particularly men, are off the charts in terms of they're 100% likely to vote for Trump. And women, they shade the numbers compared to men. And so that somebody who's like nearly certain to vote for Clinton would say, 75% probability of voting for Clinton. And that's what explains the problem in that survey. So these enthusiasm differences that affect turnout are ones that are going to be conflated with how people say they're going to vote. All right, I got to move a little quickly if I can get all my lessons. So this is going back and just weighting counties by their actual turnout and what the implied change in the weights that you need for counties depending on their percentage voting for Trump. It's pretty huge. At the extremes, there aren't a lot of people in these categories. You need 10% changes in the weights. That's not a feasible solution because I don't know before the election how many people are going to vote in each county, but after the fact I know. And so there's no sort of partisan weighting going on this. It's just saying how much do you have to change the weights to reflect turnout. And the overall effect, if you did this, is a 1.1% change in the Clinton lead, which is over half of the error that we made. Okay. So next thing are phantom swings. So in 2012, we noticed these big swings after the presidential debates. Because we were running panel studies, we went back and looked at were there changes in how people voted, and we found no net changes. So these were called phantom swings in a paper that I did with Gelman, Gull, and Rothschild. That's in QJPS. So Alan Abramowitz was following the Ipsos polls, and he noticed a big correlation between party ID and their polling results. And so Andy did this blog post basically saying, you should weight by party ID. I don't actually agree with that, but it would have saved some people a lot of trouble. So this is an online panel of primates by a company that does a lot of surveys. You can see the party ID difference, Democrats minus Republicans, is amazingly correlated with the Clinton lead over Trump. So if they'd weighted by party ID, their numbers wouldn't have bounced around. This is a large TV network that begins with an A that did daily tracking. Again, these are daily samples of about 250 people, so there's more noise. But again, you see essentially their vote changes were nearly perfectly correlated with party ID. So you'd have to believe that people were changing their party ID on a day-to-day basis. They showed in particular, well, I'll show you what they showed. So this is the daily tracking by the network poll, which in some days showed things close to 25-point differences over, I guess, a 3-day period. So you're getting enormous day-to-day variations in vote. If you weight these by party ID, about half of it goes away. So if you weight by party ID, you will make your numbers a lot more stable. My general view has been weighting by party ID is very risky in the sense that you don't have good targets for party ID. Party ID as measured in the exit poll is not particularly well correlated with party ID as measured in phone polls. So I don't know what to use for targets there. So we've come to the point of view that you should use past vote as something that you can get at a low level of geography. And the opposing view is that recall a past vote is unreliable, and therefore you shouldn't use it to weight. Well, we don't have to use recall. We have plenty of people who we interviewed in 2012, so we can take their vote as reported in 2012 and use that.
Before the election or after the election?
Before, after, in between, whatever you want.
But isn't there this halo effect after the election?
No.
It used to be.
So, this is asking people in 2016 how they remembered voting in 2012. And it turns out the stability is amazingly high.
No, but your baseline vote in 2012, was that after everybody knew who the winner was?
So it turns out it makes no difference that the pre-election 2012 vote is as correlated with the post-election 2012 vote as the 2016 recall is with either of those. It's like a one-factor model will explain all of this. I went back and I looked at the literature, and there are 30 or so papers on unreliability of recall. And they're almost all based on independent samples getting different estimates at 2 points in time. Now, it turns out there is about a 1% bias, and it comes from people who said they didn't vote. These people over-report voting for the winner. But if you can deal with validating past vote properly, the people who actually voted remember how they voted. So the only problem is here. And there are, as best I can tell, 2 studies in the past that use panel data to actually see are people giving stable responses at 2 points in time. And both of them found that they were. And we've done this on tons of variables, and for any kind of behavior, it's rather good. So we can actually calculate transition rates by groups between 2012 and 2016. We find, for example, for Obama 2012 voters with a high school education or less, 11% of them switched to Trump. Okay, so there's some movement here. That's bigger than this. This is a fairly small group. Overall, it's basically about 95% stability, but there is some movement here. And you can see the same thing in reverse on the Republican side, that people with a postgraduate degree, they're switching to Clinton at a somewhat lower rate. But the big thing that happened is that these people ended up voting for Gary Johnson. And given how close the election was, this thing here also hurt
So what is that huge other category there? 4%
So these are people saying they didn't vote, for example.
who didn't vote at all?
Yeah,
It's
not very big. What?
That's not McMullen over there.
He's pretty small nationally. I don't think he is in that category, but the only place he got significant numbers of votes was Utah.
Is there a sense of why for the Romney voters that you're getting the increase in not voting, especially as education increases? Because I guess that would be the opposite of what the usual prediction would be, that as education's increasing in general, you're more likely to be voting.
Well, this is conditional on having voted in 2012.
I see.
So I think we've taken most of that out. That'd be my guess. These are also model estimates, which of course are also conditional on our bad turnout model. So I wouldn't want to push this too far on that. Okay. So I think this was, by all definitions, an exciting campaign. However, there are our estimates of what the vote split was. We were consistently a little too high on what the Clinton margin was, but we don't really think anything happened. There are some people who claim the Comey letter made a big difference. So we looked at stability. So the way we structured our interviewing was everybody did a baseline survey in August and early September. And then we divided our panel into groups. So we interviewed about 5,000 a day up to the election, trying to get 4 pre-election waves and then 1 post-election wave. So what we can do for every person is look at their past interview and say, which the time lag varies. It can be as low as a few days and as long as about 3 weeks. And we say, how many of them are stable? And what you see is among Trump and Clinton, the red and blue, they're almost perfectly stable. It's the third party candidates are bouncing around. There's smaller groups, so the estimate is noisier, but much lower stability for the third-party candidates. But basically, if you knew somebody was a Clinton voter on Labor Day, you knew how they were going to vote on Election Day. The amount of switching, the axis range has changed. The previous one was 0 to 100. This is 0 to 1.1%. So these are the changes that you see. Here's the Access Hollywood tape. It was released on this day, so some people may have taken the survey early in the day, so I generously add another day. Any effect it had to be after the fact, but it's hard to argue. It's just bouncing around a lot with relatively small effects. If that can't hurt a candidate, can this? Again, doesn't look like it. So in terms of change from Clinton to Trump, if it was having an effect, it wasn't on those voters. Abstention, so one thing you could do is decide that you're not going to vote. A little more evidence of this. So it looks like at least after the fact, it's a little higher, but they're amazingly correlated. Why would you have decided to abstain voting for Clinton at the same time? And certainly not much happening here unless you're going to argue that's something. But again, these are pretty small numbers. That's 1 to 5%. Maybe undecided. So there are two ways you can go. You can go from undecided to vote for one of the candidates, or from voting for one of the candidates to undecided. So it turns out this category bounces around a lot. So you've got something like a quarter of the people switching to one of the major candidates. Again, it's hard to find a lot of effect. The base here is there are only something on the order of 5 or 6% undecided, and there's about a 5-point effect there. That's pretty small.
So do you not, this is just on, averaging over the population, but even if you just look at women, Access Hollywood, nothing?
Nothing. I've sliced this 8 which ways and can't come up with anything.
So what are we seeing if we look at the difference around October 25th? Suddenly there's a big jump up in the red, down in the blue.
Well, a big jump is saying 10% of 5%, but it's consistently, Trump is gaining at the end of the election. That's clearly the case.
Undecideds are switching to Trump.
Yeah,
primarily.
but it starts before this, and the level is pretty constant. And you got to take the difference between these two, that's the net change, multiply it by the size of the group. And we're down to a pretty small group. 10% change times a 5% size group is half a point.
And your scoring switching, this is based on panel data, so these percentages are, you've talked to these people before and they said something before, and
Right.
now they're saying something else.
Yeah.
And you make a cross table basically, after all the weighting, but basically it's this.
There actually is no weighting in this.
Oh, it's just a-
I'm trying to estimate a model for this where, the latent variable you'd like is your position yesterday. And what I observe is your position, a week ago or 2 weeks ago. So, it's a big missing data problem. It's the right way to deal with it.
But so any data is, you know what they said today, and you know what they said anywhere from yesterday to 2 weeks ago, and
That's right. But it's conditional on what your prior group was.
yeah.
That's the base for this. Okay. And if you look at conversions of non-voters, again, you see Clinton was doing somewhat better early on, and then Trump does better towards the end. But you don't see any sort of if you were expecting to see some big movements with these events, which seemed like pretty big events, we didn't find them. And here's the net gain by day. So what you can see is that Clinton was essentially winning, increasing her lead over this period, and then Trump picks it back up at the end. Okay, so that version is, it was not much happened over the course of all those events in the campaign. Okay, last thing. So in 2012, Nate Silver predicted all 50 states correctly. And appeared to have magical forecasting powers using unspecified methods to get the election right. It turns out a few other people also got all the states right. Some political scientists that you may know, including Sam Wang on the right, who said that he would eat a bug if Trump were elected president. Here are the forecasts. So, there are a lot of people doing forecasts these days, and a bunch of them had, like 99% chances that these states would be Democratic. It didn't go that way. And you had various probabilities of winning. The Huffington Post, which was Natalie Jackson and Sam Wang, were the highest at 98, 99%. Nate Silver's defense this year is, hey, I said it was a 70% chance. You don't complain to the weather forecaster if he says there's a 30% chance of rain and it rains. Back to that in a second. Here's Sam Wang eating a bug. We had the good sense not to put this out. So here's the draws from the posterior distribution of the vote. So, we're not too unhappy with this number. The outcome was in here. But if we'd put out an electoral vote number, we would have, our point estimate would be 314 with a 92% chance of a Clinton win, which we didn't release. And why was that? Well, if you've seen all the things previous to this, you would see that there's bias in these estimates. And we do the best we can to remove the bias. But the thing we're estimating still has bias in it. And this calculation here assumes there is no bias. So what can you do about that? So one thing you could do is essentially take past estimates and figure out what the typical squared bias is. Subtract out sampling error. You can estimate sampling error for these models pretty easily, and come up with a component of variance that is the bias in the survey. So when we do variance estimation, we're assuming no bias, or at least we're computing a variance around the expected value, which is not the thing we're trying to estimate. So one way you could easily adjust the probability estimates is to add in a component that probably has on the order of a standard deviation of about 2 points, which would smooth these estimates out and maybe get you down to kind of Nate Silver-like number of 70%. You still, if you're assuming the thing, well, so the errors clearly were also correlated across states. Nate had some sort of method. He doesn't explain how he did it. He claims it had something to do with CCES, some regression he ran on that estimated correlations across states. I can't imagine what that regression would have been, but whatever. It got his number down, primarily because he'd been doing these forecasts longer and found out that people objected when he said there's a 99% chance of anything. But there's essentially an ad hoc method of estimating variance, the squared bias across the bunch of elections and averaging squared bias and adding that to your variance estimate. And that would give you a mean square error estimate.
So you basically, so your model gives you an estimate of variance, and then you basically use a prior of your bias, square it, add it together, and then you say that's my mean squared error, and then look how far your point estimate is.
Right.
Basically make a new interval on that mean squared
Yeah.
error. Right.
And then there's a fancier version of this where you take a whole bunch of survey questions, you fit the model on it, and then you have a calibration survey. And you view the questions as draws from a distribution of questions. And so there's essentially a hierarchical model for questions, which would be equivalent of races. And I've tried this. So far, it's kind of tough to get what look like reasonable estimates out of it. They were suggesting more on the order of add like 5 or 6 points, at which point all your confidence intervals cover anything, and the newsworthiness drops. But the basic answer is don't believe your standard error estimates that come from these things of averaging 30 samples of 1,000 and pretending like you have a random sample of 30,000 that has essentially no variance in it. So that would have fixed that.
Doug, that's suggesting that generally when we take any survey, there's a huge design effect now.
I wouldn't call it a design
Something
effect.
like a design effect, that we should be inflating our standard errors by X.
All right, so there are kind of two stages. The first thing is you're fitting a model. So even if you're just raking, there's implicitly a model that is going to increase the variance of the estimate. So that's what people are normally doing by a design effect. And a reasonably good approximation there is to multiply by 1 plus the squared coefficient of variation, the variance. That's the old Kish correction. That will get you kind of what the I have a paper that shows that gets you a conservative estimate of what the sampling variability is. But there's this other thing, which is a squared bias, which I wouldn't call a design effect. It's it should come from some kind of selection model. The first thing can be done as a complete design-based inference. You don't have to assume anything about the underlying process. The other has to come from some kind of model where you're assuming these things are drawn from a distribution.
The question though is, what are you suggesting we inflate our standard errors by?
A lot. I'm not willing to say how much. Anyhow, that's my story, and I'm sticking with it.
We have a few minutes for questions.
Yes.
I guess two-part question is, the first part is just preliminary. Do you actually have this data for 2004, so that before there was an Obama effect? Or, I mean, I would think that now that you know what's going on, you should be able to go back and predict the 2008 election based on your new 2004 data set.
Well, I hate to say it, 2004 data is a bit of an archaeological dig that one database administrator decided the data that old wasn't worth keeping, and to save disk space, which must have cost a couple dollars, deleted most of our 2004 data. I have good data from 2006 on. So,
is there no way to get estimates of the size of the bias based on, I mean, it's actually not only the turnout question,
right,
and the the response rate to the poll, but the question of whether or not people are replying honestly to the poll. Those are all, aren't they all?
So there's lots of data going back quite a ways, so like the Roper Archive has, and we've collected, I don't know, about 500 polls since the 1990s from there. And, as best we can tell, all of them suffer from about the same biases and size of bias and so forth. So it should be possible to estimate that. There is a paper by Gilman, Gohl, and Rothschild that takes, I think it's several thousand surveys and estimates a variance that POQ rejected the paper, not wanting to hear the result. They claimed that the variances were underestimated the standard errors were underestimated by a factor of about 2.5.
So it seems like the biggest problem, maybe feel free to correct me if you don't think this is the biggest problem, but the biggest problem is that we don't have a survey-based measure of likely voters that we can trust even in the least.
Right.
So has there been any work in, like, maybe using some machine learning model to just, maybe pool all years you have so far, take some machine learning model, take whatever covariates you have on these people and try to predict turnout regardless of year and then see how well that does?
Yeah, so the Catalyst file has their likely voter estimate on it that is based on some kind of classification model. The thing we're trying to map is survey responses into vote, and so at that, so they're kind of, you want to do something that combines the survey response with past voting behavior, and so you'd like something to calibrate off of on that. We haven't been able to do anything very good on that, but I think if there's a graduate student looking for a thesis topic, this is one that could be pretty useful, because we are, we get turnout way wrong. We've known we've gotten it wrong. The political science literature on turnout is based on survey responses that are known to be, substantial overestimates. I'd say the other thing is getting registration right solves, 80% of your problem. So, we viewed it as if we can figure out who's registered reasonably well, then, even if our turnout models aren't very good, it's not going to make that big of a difference.
So thank you, that was really interesting. I'm kind of intrigued by hindsight bias in terms of seeing what went wrong, and I'm wondering if you put all your lessons and apply them to the next election, how confident you are that you might get closer to the right.
Well, I'll know in 6 weeks.
Or how much has your confidence been increased by doing this work?
So in 2004, we didn't put out any numbers because I didn't trust them at all. And, I think they've gotten better every year in terms of my confidence, subjective confidence. In terms of objective, the squared error and so forth has bounced around pretty much in the same range. So I don't, I sort of feel like at this point I have a intuitive idea of kind of what the range of errors are that come from something where there is no, the underlying inferences are not design based, so there aren't any guarantees that you can make. And, if you've got, I don't know, we must have done, I've got some data set of, I think it's close to 1,000 races that we've done. So we have a pretty good idea of kind of empirically how well it does. And within those bounds, I feel pretty confident. But, you're going to get a 5 sigma event at some point. Steve and Gary.
So you've pulled in the UK, the US, elsewhere, and you've had a bunch of misses, and you've done a lot of diagnostics on those misses.
Yeah.
Are the same things going on with the polls in each of these different contexts, or are they fundamentally different?
Well, usually it's not the thing we fixed that we thought was the problem in the preceding election.
Well, is Brexit, is the polling miss in Brexit the same as the polling?
Brexit, we did pretty well. We had Leave ahead by a point pretty much over the campaign.
But you pollsters generally.
All right, so let me tell you some of the lessons from the other ones, since I assume I have some time here. So in the UK, we learned that pollsters were not weighting by education. Second, we learned that they didn't know what the education distribution was in the UK population. They were misreading the tables. I learned this year that there were some university, academic pollsters that didn't weight by education. After the election, they said, gee, if we'd done that, it would have fixed our problems. And, my jaw kind of dropped, because if you look at the samples, they're just so obviously way off. And, they're 15 to 20% of the people have a postgraduate degree. The number is 6. And it's like, you aren't fixing that. So those are all things I knew before I started this, that we found various problems. We have run into turnout problems. So in Brexit, Scotland had a 10-point turnout decline in 2016 versus 2015. And there's no good turnout data in the UK. There's no voter file. There's no CPS equivalent that tells you how many people voted. They don't know how many people vote by mail. They actually mix the ballots before they count them. So nobody knows, what fraction of the sample should be mail ballots. The things we got early on were we realized that our panel was recruited, had too much interest in politics. So what we did is we added that into our weighting variables, and we do a somewhat ad hoc thing of imputing political interest from Pew surveys, and that improved things enormously from 06 to 08. 08 and 12 we did pretty well, and we didn't make any major changes. The main difference we did between 08 and 12 was that creating a frame that had pass vote on it. And that came from observing what happened during the debates in 2012. I think that, We tell people exactly what we do, but we don't share the data with them because it's like, go do it yourself.